I'm Chad with Detec Systems, and we're about to do a mock-up demonstration of how our vertical scanning unit works. It's just one of our handheld portable scanners. And so we're going to be testing this polyurea, and the polyurea is sprayed over our True Ground primer you can see over here. And the True Ground primer will make a conductive substrate under the membrane. So you can't really, with a visual inspection, see any breaches or discontinuities in the membrane. So let's see if we can find anything with our leak detection. So the first thing you're going to do is you're going to set up your scanning device. You're going to set up a lead to building ground. I've established a grounding point by embedding a piece of foil tape under. So once you have your testing unit set up, you've established your grounding contact, you've checked for continuity. The next thing you do is you're going to wet down the area. Just light spray water. You're not flood testing, you're just wetting it down. And then once you have it wetted down, you can hold the testing lead in one hand and the sponge in the other, and the electricity is going to actually go through my body to complete a circuit if it hits a breach. So as I'm going along, it's trying to complete a circuit, and when it finds a point, it completes a circuit, it will hit an alarm. So you can see I'm hitting an alarm. And I can also use my finger to complete the circuit, and you can see it's just that tiny pinhole. So you can see this is the pinhole we found. It's about a 32nd of an inch, I would guess, and there's probably no way you'd see that on a real life project. So how we'd actually test in a real life project, especially for vertical surfaces, would be with a roller such as this, and it works the same way as the sponge or even your fingers, just trying to complete an electrical circuit. So I'm going to turn my device back on. You plug it into this hole right here, and you can see it's already finding the breach, but in particular, right when it rolls over the breach, it's going to trigger an alarm, and you know there's a breach somewhere along this line. So is what I do, I turn 90 degrees, and I test the other way. Oh, and so now you know along this axis and this axis there's a breach. So now we know that there has to be a breach along this line, because that's where it triggered an alarm when we moved in this direction, and then when we went 90 degrees on the other axis, it triggered an alarm right here. So we know that that breach has to be roughly at the intersection of the two, and you can verify that by grabbing a hold of the roller or the lead with your hand and just doing a finger test. And our technicians in the field will do this test as well. So you can see it's hitting the alarm, not over here, but right where the breach is. So based off this pinhole that we found, you can see that this is really a quality control test based off the laws of physics. It's not a visual inspection. Not saying visual inspections aren't important, but through electronic leak detection, you can really identify your discontinuities in the membrane and rectify them before overburden goes on it or before contractors leave the site, to make sure that you're not handing over a building that's already compromised. You can also do this test on existing buildings if the membrane is exposed. But again, it's the same requirements where it requires a conductive substrate directly under the membrane.